Now, in group theory, after properties of group, let us start the topic subgroup. So, first, see what is subgroup. The definition is let GO be a group and let H be any non-empty subset of G. Then H is said to be a subgroup of G is H is if H is itself a group with the same operation of G. That means H has to satisfy all the properties of group, that is closure law, associative law, existence of identity and existence of inverse with the same operation, not the other operation, with the same operation of G. The example of the subgroup is, we have earlier seen that Z plus is a group. Z, the set of integer together with the usual addition forms a group. Now, if we take E, the set of all even numbers, then clearly E is the subset of Z. Even numbers is the subset of the set of integers, and we can easily verify that E plus also forms a group. So, if we uh, take two even integers and we add the two even integers, then we get an even integer. So, closure law satisfy. Even integers are also integers, so associative law holds in E also. Even integers start with 0, so existence of identity also holds in uh, E. And inverse, there is plus 2 and minus 2. So minus 2 is the inverse of plus 2. So uh, in existence of inverse also holds in E. So E plus is a group, but since E is a subset of Z, so we will say that E plus is a subgroup of Z. Now, these are two important definitions I want to discuss with. First one is the order of the group. This is defined as the number of elements in a group is defined as the order of the group. So if a group is finite, then its order is finite, and if the group is infinite, then its order is also infinite. So order of group we can write is O bracket G, order of G. So if we take an example, G is equal to 1 minus 1 I minus I, then order of G is 4, as there are 4 elements in G, 1 minus 1 I and minus I. We can write O bracket G is equal to 4. Now order of an element of a group. Let GO be a group and let A be any element of G. Then the integer n is said to be the order of an element A if A to the power n is equal to E. E is the identity element and n should be the least positive integer. We symbolically write it as order of small a, order of the element A. Now with the same example, if G is equal to 1 minus 1 I minus I, then G forms a group with respect to multiplication. Here, if we take the first element 1 of G, then we easily see that 1 to the power 1, we will get the identity element. Clearly 1 is the identity element of G for multiplication. So order of 1 is 1. Minus 1 to the power 2, we will get the identity element 1, so order of minus 1 is 2. I to the power 4 is equal to 1, so order of I is 4. And minus I to the power 4 is also equal to 1, so order of minus I is also 4. So that's why we will explain the